Okay, this is our makeup class, and I will start from this page where I discussed this twice, the marginal cost and marginal revenue, marginal analysis. That's what we're going to do. In this case, I have a cost function. The marginal cost is the derivative of the cost function, and it also, the marginal cost tells you what the cost change is per unit. So particularly in this case, the cost change per unit to make that particular 1701st unit is about $2.98. And so that's basically what marginal cost, marginal revenue is. In this case, the average cost is the total cost divided by the number of units produced, and this is the average cost function. Take the derivative of the average cost function, that's the marginal average cost. Okay, so let's do more problems in the next page. I have a cost function given by 200,000 plus 265x. Well, the way we think about this is this is a fixed cost. If you produce 0 units of items, in this case recliners, you would pay this much money just for setting up the company. Okay, this could be the manufacturing company, also including salaries of employees. But per unit, it's costing us $265 is the way we want to think about this kind of cost function. So this is fixed cost, and that's a variable cost is what we call it, per unit. It's not as simple as this in most cases, but for example, in this case, it was not really that simple. But sometimes it's as simple as that. So in this case, we want to find what's the actual cost incurred for producing 201st and 401st recliner. So to get the cost for 201st recliner, we're going to calculate the cost to produce 201 recliners, and then the cost to produce 200 recliners, and take the difference. That's the actual cost. Okay, so that will give us 200,000 plus 265 times 201. That's the cost for 201 all in all recliners, minus 200,000 plus 265 times 200. I don't know how much this is. We can just put it in the calculator and figure out. But I can tell you that because this 200,000 cancels out and 200 copies of 265 cancel out, I can tell you that the final answer is $265. Okay, so to produce that 201st unit, the cost is 265. All right, to do the 401st, we're going to calculate 401 minus compute the cost for 400, and that again is 200,000 plus 265 times 401 minus 200,000 plus 265 times 400, and again this will come out to be 265. Okay, so that's $265 to produce the 401st. Now let's calculate the marginal cost. C prime of x Derivative of 200,000 is 0. Derivative of this is 265. It's the constant function 265. So if you plug in C prime of 200, that is 265. And this makes sense because the rate of change per unit is 265. And it also matches to this answer that we get. And C prime at 400 is also the constant 265. And this both match with the cost per unit of production. In both cases is $265 per unit, okay, per unit. The average cost function is the cost function divided by x. In this case, it's 200,000 plus 265 x divided by x. This is 200,000 over x plus the constant 265. So on average, it's costing this much per unit. So if you produce x units, what happens to the average cost function when x is very large? So when x goes to infinity, this guy goes to 0. So what happens here is, if you're producing, say, 100,000 units, on average, your cost is 265 plus $2. So 267 on average, because you have 100,000 units produced, you pay 200,000 plus 265 times 100,000. So that much money you costs you, but you produce 100,000. So on average, it's costing you 2 plus 100, 265. Well, if you produce 1 unit, on average, it's costing you, or maybe 10 units, it's costing you this over 10 plus 265. So that's just only producing 10 units. Per unit, it's costing you a lot of money. So what happens as x goes to infinity? When x goes to infinity, the value 200,000 over x goes to 0. So what that means is the average cost approaches $265. Approaches to $265. Okay, so on average, so the more you produce, the closer to 265 you pay per unit, because again, this is fixed cost to set up the unit, to set up the company, the factory, the machines. Then that's what you pay per unit. So as you produce more and more per unit, it averages out, and it gets closer and closer to $265 per unit. The next one, so we remember when we talked about the price, we have the price function is a function of unit x, so price per x per unit. Now if you want to calculate the revenue is the price multiplied by the number of units sold. So say you're selling x units, each for a price of p. If the price is like $5 a unit, then you are selling x times 5. And the revenue, which is what you get on the cash register, is x times p. And so it will be 5x. So if you sell 10 units, you have $50. If you sell 100 units, you get $500 on your cash register. If you sell P units, if you sell X units, X times P for the price of P, okay? And usually the price looks kind of like that. So we can calculate the revenue function by multiplying X by P, okay? Now the profit is the difference between what you have in the cash register plus how much you paid to produce the unit or to bring it to your store. That's a cost. So that's the profit. Okay, that's a clean profit that you're making. Now, in this example, the price per unit is this much. So let's find the revenue function. So the revenue function is X times P. In this case, X times negative 0.08X plus 600. This is negative 0.08X squared plus 600X. That's the price function. Marginal revenue is the derivative of the revenue function. This will give me, take the derivative of this, that's 2 times 0.08X negative plus 600. That's the marginal revenue. So let's see how we can maximize the revenue. Okay, how many do we need to produce and sell to get the maximum revenue? So to do that, we will be going back to our first derivative analysis kind of work that we did before this, which is take the first derivative, set it to 0. In this case, minus 0.16x. So we set this to 0 plus 600, set it to 0. This gives you minus 0.16x equals minus 600. This gives you x equals minus 600 over minus 0.16. This is 600 divided by 0.16 is 3,750. Now that's a critical number. Once we get the critical number, we put that as 3,750. From here, I don't go to minus infinity because it doesn't make sense to produce minus infinity or a negative number of units. So I'm just going to start from 0 up to infinity. Let's see what r prime of x does. Take a test point and another test point, okay? If I take a test point of, say, 1 and a test point of, say, 10,000, I'm going to plug it into r prime. R prime of 1 is negative 0.16 times 1 plus 600. That's positive because this is a tiny number. Okay, so that is, sorry, this is positive. And r prime of 10,000 is negative 0.16 times 10,000 plus 6,000. And this guy is 1600 negative plus 600. This is negative. So r does increase and decrease. So we have actually not only a local max, we have a global max because it's going down all the way to infinity. And start from down, there's only one critical value. So this should be an absolute max. So producing how much was it? 3,750 units will yield maximum revenue. Okay, so what's the maximum revenue? So we're going to stick that into the revenue function. 3,750 and that would be, we're going to put it in the revenue function. So that will be 3,750 times negative 0.08 times 3,000, or maybe I'll use this revenue function instead of this one. Okay, so I have negative 0.08 times 3750 quantity squared plus 600 times 3750. Okay, I'm going to use my calculator. Negative 0.08 times 3750 squared plus 600 times 3750, and that gives me 1,125,000. Okay, so that would be the maximum revenue. Now, if we produce more, our revenue decreases. If we produce less, our revenue decreases also. So to get the maximum revenue, we need to produce 3,750 units. All right, let's go to the next page. In the next page, I have a cost function. So the revenue function, remember, was negative 0.08x squared plus 600x. This was the revenue function. This is the same company. So this television producing company estimates that this is the cost for producing X units of TVs. So the profit is the revenue minus the cost. This is negative 0.08x squared plus 600x minus 180x plus 200,000, and this will be negative 0.08x squared plus 600 minus 180 is 420x minus 200,000. I'm just distributing the minus and subtracting. So the marginal profit is, we need to differentiate the profit function to get the marginal profit. This is negative 0.16x plus 420. That's the marginal profit. And let's calculate the derivative at 100. This will be negative 0.16 times 100 plus 420. And that gives you 420 minus 16. This gives you 404. Okay? 420 minus 16 gives you 404. Uh-oh, sorry again. So what does this mean? It means that the profit for producing the 101st TV is approx $404. Okay, so that would be the marginal profit. Okay, just the next unit would cost and it would give us a profit of $404. All right, here's another example. The monthly profit for a condo leasing company for leasing X condominiums is this. This is the profit function. They did calculate the profit for us. They didn't give us the price per unit, and they didn't want us to do revenue or anything like that. So calculate the actual profit realized from 81st condo, assuming 80 condos have been rented. Okay, so what we want is P of 81 minus P of 80. Okay, this is minus 10 times 81 squared plus 1950 times 81 minus 70,000. That would be P of 81 minus 10 times 80 squared plus 1950 times 80 minus 70,000. This is what we need to calculate. All right. I'll pause the video and calculate. And okay, so I calculated this, and it came out as 22340 for the first one, minus 22000 for the second one. So that would give us $340. Okay, so that would be the profit for renting the 81st condo exact value. Let's calculate the marginal profit, and we're going to plug in 80 and see the comparison. That would give us minus 10x minus 20x. I'm differentiating this, taking the derivative of that, so minus 20x plus 1950. So that's the profit, the marginal profit. So we want to calculate P prime at 80. This is minus 20 times 80 plus 1950, and that gives you gives you 350. So it's almost the same. They are almost equal. They're not exactly. When you compare, this is exact, and this one is approx, and this one is based on the trajectory or trend of the profit function P. That's the exact calculation for producing the 81st particular unit. Okay, 2 more pages to go. Here I have a profit function. Marketing function. The company determines the demand for wireless headphone is, so this is P denotes the headphones unit price. So this is unit price for X quantity. So the revenue is X times P. This is X times minus 0.085X plus 900. And this is minus 0.085X squared plus 900X. I will pause this video and then fill it and then come back to it, okay? Because this is similar to what we did in the previous page. Okay, so I calculated the revenue function as X times the price, the unit price, and this is the revenue function. Okay, and to get the marginal revenue, take the derivative of this function, which is this 2 times 0.85. 0.085 is 0.17. Once I do that derivative, that gives me the marginal revenue function. Okay, to find the number of headphones demanded to produce the maximum revenue, I set that derivative to 0, which is set that to 0 and solve, and it gave me this number. Knowing that we're talking about X units of production, number of headphones, rounded it to an even integer, and not even, but to a whole number. Okay, so that's just the potential maximum production. We're just gonna have to check using first derivative test. Okay, so I did the derivative function, tested it at 1 and 10,000. At 1 it's positive, at 10,000 the first derivative is negative, which means that the revenue function is increasing up to this unit and then starts to decrease from that unit on. Okay, so that means that I need to produce this much unit for maximum profit. So that's what I said here. To get maximum revenue, not profit, I said profit, I meant revenue. To get maximum revenue, the company needs to produce this many units. Okay, and the maximum revenue is, you plug this into the revenue function, not the derivative, but the revenue function here. Okay, plug that into the revenue function, it gives you this much. Notice that I rounded this because it's a number of units, but I didn't round this because it's profit. So 2,380,352 and 94 cents. So I didn't round that one. Now from this question follows the next page. I have the cost function given. Remember, revenue is this, so we want to find the profit. Is the difference between the revenue minus the cost, and it came out to be this function. Now the marginal profit is the derivative of that function, so it is 2 times 0.85 x squared negative plus 691. Okay, the derivative of 170,000 is 0. So I get that derivative, and they want us to find the maximum profit. So I set the derivative to 0. I got this number, rounded it to a whole number, and I did the first derivative analysis once again by taking test points, and it gave me that this value is actually, this gives you the maximum profit. So I calculated the maximum profit. I plugged it into the profit function, into this function here. Okay, I plugged it into the profit function, and that gives me this much. And so the profit, maximum profit, is $1,234,355.88. Once again, you can see that I just did not round. I rounded it to 2 decimal places. It gave me 0.875, rounded it to 2 decimal places, because it only makes sense to round it to 2 decimal places. It's money. All right, so I will also do one more video on the remaining part of what we were discussing today.